Hello everyone and welcome, and in this particular video I'll be sharing with you how to perform chi-square in Microsoft Excel. By the way, if you're new to my channel, consider subscribing and clicking that notification bell, or probably share this particular video to those people you know that might need this video. Alright, in this particular video we'll be talking about chi-square. Now chi-square is a test of relationship with two categorical variable. Remember, it's a categorical variable, meaning it's in the nominal scale among the certain hierarchies of variables. Now chi-square is actually a test of relationship, whether or not there is some kind of a relationship between categorical variable A and categorical variable B. Now again, what are categorical variables? These are unordered, right, unsequenced, and rank set of data. Let's say, for example, gender, some other descriptive data such as hair color or color of the eyes, etc. All right. Now, in this particular video, I'll be sharing with you how to perform these particular calculations. Now, chi-square is simply the sum of the observed value minus the sum of the expected value squared divided by the sum of expected value. That is the chi-square. Now, chi-square actually have what we call as a predicted value. And so in chi-square, you analyze the observed value against a predicted value and calculate the association or independence of the said data set. Now, before you perform certain chi-square, you should have a prediction called hypothesis, right? A hypothesis is a prediction of a certain observed value, all right? You predict something based on what you can see, and you gather information, data, and then perform chi-square to determine whether or not you reject or fail to reject such a particular hypothesis or prediction. An example of hypothesis or prediction testing is this. You're in a school with 10,000 population, and so you predict that there is a 50-50 biological sex distribution of XYZ university. All right. And you got a sample of 100, and then you found out that there are 26 male and 74 female. And the predicted value in this particular scenario is 50-50, of course, because you got a sample of 100. And when you perform chi-square on that, you will be able to know whether or not this particular prediction is rejected, or you fail to reject this hypothesis. Now, another example is, let's say you're in a restaurant and you want to determine whether or not hair color is a determinant factor in customers' choice. So what you're going to do is you get a sample and calculate the chi-square to determine whether or not the hypothesis is rejected or not. All right. There are two kinds of interpretation with respect to chi-square distribution, and here is a table that is displayed in your screen. Now, you can determine whether or not you reject or fail to reject any prediction in chi-square by using two several interpretation method. First is by looking at the critical value. All of these is the critical value, right? The critical value. Now, here above is the p-value, or the predicted value, or predicted or probability value, right? So p-value. And then we have here the degrees of freedom. Now, degrees of freedom is simply calculating only how many cells or how many rows and columns do you actually have. This is simply rows, number of rows of your data set minus 1 times number of columns of your data set minus 1. So that is the degrees of freedom. Now, in this particular example, there is only 1 degrees of freedom. Well, the degrees of freedom is actually the ability to choose specific cell. Let's say, for example, there are only 2 here. So when 26 and 74, there's only 1 degrees of freedom because that is a column minus 1. Right, now there is a predicted value here of 50 each because we have 100 sample, and so uh, there's also 1 degrees of freedom in this particular example. Anyway, I'll be giving you an example of a calculation later on in this particular video. All right, so that is how you interpret the chi-square. And so let's say, for example, um, your critical value is 3.84, meaning that your rejection value is around this area, right? And you fail to reject in this particular area, meaning if it is less than the 3.84, then you fail to reject the hypothesis, right? Here, you will reject the hypothesis, all right? You will reject the hypothesis. In terms of the null hypothesis, when you are using what we call as the alpha or the probability value, then when it is greater than 0.05, right? Greater than 0.05, then you fail to reject, right? When it is lesser than 0.05, then you reject the hypothesis. I'll be giving you an example, that one later on in this particular video. So you can actually find this particular table of interpretation in Google, right? You can just search this one, or you can actually perform certain calculation here in Excel to determine the critical value in this particular table, and it's actually almost automatic. All right, there you go. Here is an example of a data set. Now, in this particular example, we will be trying to determine whether or not educational attainment is a determining factor for a consumer food preference. All right, educational attainment versus food preference. All right, so the prediction is, the hypothesis is, there is no relationship between educational attainment and consumer food preference. There is no relationship. All right, there is no relationship. So if it is, we will be calculating what they call as the p-value of this, and so we'll be able to determine whether or not this is accepted or rejected, right? So this is our prediction. This is our hypothesis, null hypothesis. All right. Now, in order to perform your uh, chi-square, the first thing that you have to do is you have to look at the frequency of this by performing what I call as a pivot table. Insert and then pivot table, and then you just select the range, um, control shift and arrow down, and then after doing that, you select a certain cell and paste in the existing worksheet, and click OK. And then there you go. There is your pivot table. We'll use educational attainment as the rows and columns for food preference and values. All right, there you go. It's automatic, and uh, the data is already available. Now, what you're going to do is you have to copy this one, and then you paste values. There you go. So this is now our values, because you cannot use this one because this is a pivot table. So using this, we determine what we call as the predicted value. Oops, the predicted value. Now, in determining the predicted value, you just delete this one. the predicted value is actually equals to a grand total, right, multiplied by the grand total here divided by the total responses. Right now, before you actually uh, enter on that, you have to put the dollar signs here so that it will be fixed. All right, and here, right, so there you go, we enter, and then we can now try to drag this one, right? So you can, it is actually automatic, and of course you can auto sum this one, grand total of 49. You can also try to drag this one down, right, so that it will automatically calculate the values. Remember that you have to put the dollar signs strategically before these particular letters, numbers, and then letters and numbers in the cell, right? So it's a grand total here, auto sum, and then there you go. So these are your grand total of the predicted value, right? Grand total of the predicted value. Right, so the next thing that we have to do is to get the chi-square value, right? We need to get the chi-square value. Now, of course, we have to select this one again and paste values here, and you have to uh, remove this, right? Remove this because this time we will be using the formula, this one, this formula right here. We will be using this one in order to determine the chi-square value. Now, what we're going to do here is we are going to be getting this chi-square value, and this is by this particular formula is equals to power, right? Power, and then of course we have to add another bracket, and then that is the observed value, which is this, all right, minus the predicted value, right, close parenthesis, power of 2 because that is squared, and then close parenthesis divided by the expected value, right, divided by the expected value, which is this. So that's it. This is our what we call as the chi-square value. We can just go directly to this, and then all right, there you go. And then we have to do an auto sum to this, right? There you go. And then also here, and then right there you go. Our chi-square value is 38.25. 38.25. Now, again, in order to interpret the chi-square result, we have to refer to this particular table, right? Now, first things first, we have to determine the degrees of freedom. Now, simply, the degrees of freedom is uh, row minus 1 multiplied by column minus 1. So in this particular case, there are 1, 2, 3, 4, 5 minus 1, that is 4. Then we have 1, 2, 3, 4, and that is 3. And so therefore, the degree of freedom in this particular example is 12. That is 3 multiplied by 4. And so we can already find that one here. There is indeed 12 in the degrees of freedom, and we'll be looking to this set of critical values. Now, how do we get the critical value? How do we get the critical value? It is simply, all right, it is simply chi-test INV RT, this one. Then the probability, because we are dealing with social science, that is 0.05, right? And the degrees of freedom is 12. Close that one, and that should be around 21.3. 21.3. The critical value is 21.3. So in this particular example, we will try to double check whether or not the critical value at 0.05 is 21.3. And so here we have 12 degrees of freedom, and we have to look at the probability value of 0.05, and we have to look down, and there you go, there is 21.03. Now in this critical value, the prediction will be that there is no relationship between educational attainment and customers' food preference. All right, so the rejection value should be greater than 21.03. If it is greater than 21.03, then we have to reject this particular hypothesis. So using the critical value and comparing the critical value, the total chi-square, to the critical value, we'll be able to determine that indeed it is greater than 21.03. It is somewhere in this particular area. And so therefore, because it is within the rejection zone, we reject the hypothesis. We reject the hypothesis, which means that there is relationship between educational attainment and customers' food preference in this particular example. Now, another way of getting the same result is actually getting what we call as the p-value, right? The p-value is equals to right? Chi-test, then the actual range, right? Actual range, comma, the predicted range, and then close parentheses, and then okay. And so there you go. This is the p-value. Now remember that the p-value in this particular case, the benchmark is 0.05, right? If it is greater than 0.05, we fail to reject the hypothesis. If it is lesser than 0.05, it means that we reject the null hypothesis. And so by using the p-value, we reject the hypothesis, which means that there is relationship between educational attainment and consumers' food preference. Right? I hope that you learn something, and see you on the next video. Thank you very much.